For today's webinar, we have David Witzke back with us presenting best practices for forensic digital image processing. Without further delay, here's David.
Ladies and gentlemen, this part of the presentation is talking about best practices for digitally processing forensic evidentiary photography. When we have to consider the process of enhancing any type of imagery, there are a number of components that we have to consider and include as far as our best practices are concerned. And on this first slide, you can actually see a number of those different topics that we're going to address. But before we start, I want to talk a little bit about the different types of file formats that you may be using today. We have talked a little bit before in our last session about the camera raw files, and we want to make sure that we are using an HDR or high dynamic range value. Now, when we're talking about camera raw files, that sometimes when we capture an image, some of the detail may not be immediately visible in terms of can we see the detail in the image. However, with a quick couple of fixes, we can actually adjust the contrast so that we can take advantage of the dynamic range that is available in that file format. TIFF is, again, something that is a 24-bit color by default, or it could be 16 bits per channel or per shade, or 48 bits for the image. And then we get into JPEG. Now, when we get into JPEG compression, unfortunately, there are a lot of people that when photographing and processing trace evidence that they still use JPEG images. And if I were to be able to command you to do one thing to stop doing that one thing to improve the quality of your image processing, that one thing would be to stop using JPEG images. So for example, when we get into our fine compression, which is our high quality, that's a 1:4 compression ratio. If we get into our normal or our medium level compression, that is going to be at a 1:8 compression ratio. Or if you get into your lower level compression, that's 1:16. So it doesn't take a rocket scientist to see that by using compression that you can very quickly and easily degrade the visualization of your image. Also, once you have started degrading the quality of the image, that detail is lost forever. You can never get back the original detail that you actually started with. Now, to take this and go into just a moment and look at what happens when we have a camera raw file, that we get into what kind of detail can we visualize. And on this image that you can see here, there's actually a footprint that is on this Bowflex seat, but you can't see that. And at first glance, you might say that there is nothing there, and you might just simply discard that and not want to even try to capture or do any processing because it's not a value, and you may even try to photograph it multiple times, etc. If we just go in and do something such as a simple click, you can start seeing that there is contrast that is being picked up. And so we can then go in and look at these different components and start seeing how much level of detail is there in that image as it is being processed. And so just by making a couple of minor adjustments, that we can start seeing all sorts of detail becoming very clearly visible. This is because we have that high dynamic range at the point of capture. That high dynamic range also is going to be determinative as to whether or not you can do any kind of processing to that image. And what would you even want to do in terms of trying to process? How much detail do you have? How much detail do you need? Or can you even make more detail even more clearly visible? This is where we get into this challenge of making sure that we are using the appropriate file format and that we have the appropriate bit depth. One thing too about a camera raw file, we get into this thing called a sidecar. Adobe Photoshop creates a sidecar file automatically every time you open a camera raw file. This allows you to save your settings so that if you decide that you want to go back and reopen that image again, you do not have to start at the beginning. You could actually go in, open that image with the exact same settings and parameters that you had when you opened it initially. That will allow you to preserve or embed the data for use when you reopen an image, but also within the Adobe Photoshop settings within the history, that same XMP data is going to be embedded and preserved so that if another individual were to try to assess what it was that you did to that process, they could then go ahead and know exactly what it was that you did. So the first step is to open the file using the highest possible quality that you can possibly capture. So when you're capturing your digital evidence, I recommend that you use a camera raw file format. We talked in the last session about having a digital SLR that has a full frame imaging sensor so that you're getting more accurate and reliable contrast and you're picking up less noise. You also want to make sure that you store and preserve your original data, your original image file. And that way you can always go back to the original source if there's ever a question and you need to try to reprocess it, or maybe somebody wants to try a different technique, that they too could go back in and do that process. Then what you would do is you would duplicate your original images and you would use only those that are identified as copies for doing any of your processing. The original digital image files should never be touched. They should always be put away and reserved and saved for posterity. Once you have your original images preserved, once you then have your copy of the image, you then open that image in Photoshop. And the first thing that you want to do is to calibrate the image for accurate life-size output and measurement. I want to mention also that during calibration, there are typically two types or two different options for calibrating images. When we are calibrating images, we would have the option of either using the ruler tool to measure the size of the impression. We also have, or the distance on a scale. We also have a tool or a technique called the crop tool. And the crop tool helps us to identify whether or not there is any problem with distortion, especially when we get into perspective distortion and whether or not the camera was accurately set on a copy stand or on a tripod when the impression was photographed. So after we've done that process, we want to go through and evaluate or suppress any background color information. And that will then help us to make sure that we can visualize the clarity of the detail within the image. This is where we're going to take advantage of both the resolution in the image for the quality. We also have the bit depth or the dynamic range, which will give us the clarity. And both of these components will help us in this process in terms of evaluating the background colors and suppressing those background values. Then, after you have gone through that process, the next step is we're going to convert the image into grayscale. And the reason why you have to convert the image into grayscale is because there is a distinction between how tools work in a grayscale environment versus how those same tools work if you are in a color mode. Then we're going to adjust the tonal range or contrast within the image. There are a number of tools we're going to talk about as to how we actually use those tools to achieve this process. Then we're going to fine tune, which is going to eliminate any of the background noise. So we have dust and scratches, we have unsharp mask, we have burn and dodge. Again, we have a number of tools that we can do in this process, and we're going to talk about these processes in a little bit more detail as we move through this class. And then last but not least, what you will do is you will save the processed image using a non-compressed file format. If you want to make a note about, again, one of the guidelines that you want to make sure that you follow very stringently, thou shalt never save a processed image using a compression process such as JPEG. That is an absolute no-no. Also, one other thing that we're going to talk about, and I will demonstrate this for you so that you can actually see why, is that you are only allowed, especially during the processing of your image, to rotate the images in 90-degree increments. Now, there's a tool which is called a rotate view tool in Adobe Photoshop that allows us to rotate the view without actually changing the background pixels. But we'll, again, talk about this in more detail later. So we've talked about some of the color processes earlier and how we actually make that assessment or the determination of those values. And we have our color picker or our color wheel based upon the different RGB values and how those are all joined together based upon the brightness or the intensity value. That's how we come up with all of our different colors. We want to make sure that we are suppressing the color values that interfere with the actual visualization of the detail within our trace evidence. So when we're getting into rotating images, we get into issues that are color aliasing. It's also resampling pixels. And the problem is that it can actually change the appearance of the characteristic of the footwear impression when you are trying to analyze the level of details or the characteristic within the image. So once again, do not rotate images with colored backgrounds before processing. 90-degree increments is acceptable, or using the rotate view tool is acceptable. But going into image rotate is not acceptable. 90 degrees is permissible, but when we get into different variations on that, here's what we are talking about. If I have 3 pixels, 1 pixel red, 1 pixel green, 1 pixel blue, that if I have these 3 pixels or these 3 color values lined up in a column, that if I start to rotate that column, you can see how those different color values are then going to be affected based upon the degree of rotation. So if I am going to rotate the 3 pixels at 22.5 degrees, I now have alternating rows that are 4 and 5 pixels wide, where I've now started making up different color values. If I rotate it at 45 degrees, I'm now between 6 and 7 pixels wide. This is going to be problematic when I'm trying to make an assessment about an artifact within a footwear impression. Also, please bear in mind that the lower the resolution of the image, the more important or the more visible these artifacts become. So again, making sure that you are using sufficient resolution. Going back to our quantitative issues in terms of sufficiency, you want to make sure that you have the most accurate or the highest number of pixels you can get. You also want to make sure that you have the most accurate and reliable interpretation of those pixel values. So when we get into using things such as flatbed scanners, I need you to realize that especially if you are going to be scanning footwear impressions, i.e. your lifters, things like that, that I need you to remember that this process of scanning with flatbed scanners, that the contrast is measured completely differently between scanners and digital cameras. When we get into digital cameras, we're talking about bit depth, and we can have a very high dynamic range. On flatbed scanners, the dynamic range that you have, the maximum dynamic range is 4.0. So when we're talking about making sure that we are getting the best possible bit depth, you have to make sure that you're using the most appropriate device when you're scanning, because if you are doing things such as trying to assess color, that the quantitative value is going to vary between whether or not you are going to photograph something or whether or not you are going to scan that object. Okay, so moving right along here in terms of the scanner settings, I want to provide you just a quick view of some of the settings that you would normally use. This is based upon having an Epson Perfection V800 series flatbed scanner, but most of your Epson scanners use the same interface. So when you are going in to preview your items, you also want to make sure that you are going into the configuration settings and that you turn off the color correction, because the scanner is going to try to make corrections to the image as it is being scanned, even though you cannot see it, or even though you have no idea how much or what it is trying to correct. So you want to make sure that you go into the configuration setting, go to color, and make sure that you do no color correction. Also, when you go into your settings, your file settings, you should always make sure that you're using a TIFF file format. Again, please do not use a JPEG to scan items. One of the reasons why people tend to try to scan trace evidence using a JPEG file format is because of the file size. When you are setting up your preview and you have your marquee area that is set, the larger the marquee plus the higher the resolution is going to affect your file size. So when you're trying to create an area or you're trying to scan a very large area, you want to make sure that you do it based upon an evenly divisible number, based upon the actual hardware resolution, the actual optics of the device itself. So, for example, on this scanner has an hardware optic of 4,800 samples per inch. So if we were going to make sure that it was evenly divisible, we would have 4,800 divided by 2, which is 2,400. Then 2,400 divided by 2, which is 1,200. 1,200 divided by 2, which is 600. 600 divided by 2, which is 300. So those would be the steps that you would step down within the resolution. Be very careful about selecting a resolution value because you can start creating artifacts based upon weird resampling of the pixel values. So those are some of the key considerations, especially when you are using something that is going to be scanned. So once again, make sure that if you're scanning it, change the size of the area to scan, also change the resolution, but do not use a JPEG or compression process. The compression within scanners is actually more aggressive than what it is in digital cameras. So that's something that you need to take into account. So when we're starting to get into the color modes and we're trying to suppress the color channels, whether we've photographed something, whether it was in RGB or whether or not we've scanned it in RGB, when we start talking about these different processes, you do have different modes. So if you go to image mode, you have RGB, CMYK, lab color. Lab color is something that is pretty much reserved for digital imaging. And while there are certain advantages to it, it is typically when you're using an alternate light source to photograph something that, or you're trying to process something that has been photographed using a digital camera, or even if it was something that was scanned that has sort of a weird coloration, that again, lab color can be used for that. So you have your RGB mode, which you can suppress a single color channel. CMYK lets you blend two different color values depending upon the type of substrate that you're dealing with. You may want to consider CMYK, and lab color is going to be based upon, again, that color picker. Now, please be advised that when using your lab color, again, I want you to remember the color picker that we talked about during our first session, that when you're looking at your red, green, blue values, that in your lab color mode, channel A is going to show only the red and green values for every pixel within the image, and channel B is going to be displaying the green and blue values merged together for every pixel within the image. So this is one of the reasons why when we get into different colors and different substrates, that again, if you're using an alternate light source or other situation like that, lab color can be somewhat helpful. Also, I want you to please be advised that for the power for footwear, that when you're trying to suppress different color backgrounds, you have two very powerful options. You have a process or a technique that is called black and white, where you can adjust not only the hue and the saturation, but you can also increase the contrast of each one of those values within the color spectrum. So black and white is a very, very powerful tool. So to just take a very quick moment, when we are looking at this image, that if I were to go into my color channels and I were to try to use red, then that's going to lose the detail. If I use green, I've got sufficiency of detail. But if I go into my blue channel, I'm losing a little bit of contrast. Or some people could even say that it's even better contrast. But I can go into image adjustments and I can go into my black and white function, and I could, again, adjust these values so that I am getting the desired results with the desired contrast. Okay, so ladies and gentlemen, once we are going into looking at black and white, we can go in to look at the color values, where I can either increase the contrast or decrease the contrast, and I can actually improve the clarity or the quality of my image. And I can do this for every single color value, depending upon whether or not it's going to have a bearing or an impact within this particular image, or how much I need to adjust the contrast. So this gives me the full range or the full spectrum of detail when I'm trying to do the processing of my images. So black and white is probably by far one of the most advantageous tools for doing trace evidence processing. When we get into hue and saturation is very much akin to black and white, but unfortunately, it does not allow us to have the same type of control. But the bottom line is that when I use black and white, the end result is a grayscale image. When I use hue and saturation, I still have color that is retained within the actual image itself. So the one thing that I want to do is, as soon as I get done with my processing, I want to make sure that I go in and I suppress the background color values and convert the image into grayscale. It optimizes and simplifies the process of adjusting contrast, as well as which is again very important, it reduces the size of the file to 1/3 of its original file size. So when we are looking at this image, and if I am going to go into image and I look at image size, I have a file size that is 46 megabytes as far as the number of pixels are concerned. And again, having things being in an RGB environment. Now, if I go to image mode grayscale and I discard that value, I then go to image and image size, and I'm now down to 15.3. So once again, it is a substantial decrease in the number of pixels within the image. So when we're trying to do these processes, we want to make sure that we are using this properly. Also, when we're getting into contrast, we have a number of tools. We have apply image, where I can use blending techniques such as multiply, darken, overlay, screen, etc. I also have the ability to use shadows and highlights. One technique that almost every single person that is dealing with trace evidence uses today is a technique or a process that is called levels. Levels is the most damning and destructive tool that you could ever use in the processing of trace evidence. Levels is a destructive process whereby it actually readjusts all of the pixel values throughout the entire image. And we're talking about every single shade of gray in the entire image. And it actually reassigns pixel values, and it uses a technique called clipping that can be very destructive, and you can lose contrast, you can actually lose detail within your image. Curves is, again, something that is a good tool, but there are a couple of complications in learning how to use it. So to make a very long story short, I strongly encourage you to use two different processes, either apply image or shadows and highlights for creating your tonal range and contrast. Now, some people still want to use brightness and contrast, and while it's not my tool of choice, I'm not going to disavow the ability to use it. I just simply would caution you to use it only with severe caution. It's not going to provide you the degree or the contrast of results that you can get with something such as shadows and highlights. Also, one of the things about shadows and highlights, you have the ability to control specifically what shades of gray, whether they're shadows or whether they're highlights, that are being adjusted. And you can limit that adjustment within a very specific range of grayscale values. So again, when you have something where you have the highest possible degree of contrast, you have the highest possible degree of control using shadows and highlights. But I don't want to minimize the value of apply image, because that's one of those tools that I do like to use a lot as well. So when we're talking about apply image and calculations, because some of you may be familiar with some of these processes, apply image and calculations are almost identical functions. One of the nice things, and this is extremely important when dealing with footwear or tire tread, is using apply image, because you can actually isolate a portion of the image and make the contrast or the tonal range correction only within that area. Calculations is applied across the entirety of the channels. So it's a multi-channel process, and again, it's applied across every pixel. Apply image, it's more control. And we have tools such as area of interest tools, where we can isolate lighter areas or different contrast areas and then get the best possible results to bring up the contrast in those lighter areas. Just to give you sort of a quick view, apply image, you can use it with all color channels. It can also be done with grayscale. You can use it with duplicate copies of the same image. You can also use it with area of interest tools. So again, apply image is a very powerful tool. Calculations can only be used within two color channels. Also, one other thing that calculations does is it actually changes the contrast or the color mode of the image from a color image to a grayscale multi-channel value. Also, one of the things that you have to be a little bit careful with calculations is you could also make the image unusable with certain other applications if you forget to go into grayscale, or if you forget to convert the image to grayscale properly. So when we get into shadows and highlights, just to close the loop on this process, on the shadows and highlights dialog box, what you see on the right side of the window here, you can actually limit how many shades of gray that you want to adjust that are shadows, or you can also adjust how many highlights or how many shades of gray that are highlights. Now, if we look at our histogram in something such as levels or curves, the histogram is broken down into two different sides. We get into the side that is called the shadows, and we also have the side that is called the highlights. Now, when we're processing images, we have 256 shades of gray. So that means that there are 128 color values that are considered shadows. There are also 128 shades that are considered highlights. So by adjusting the shadows values, by adjusting the tone, I could then tell whether or not I want to use 50% of the shadows. So in this case, out of my 128 shades of gray, that if I'm using 50% of those, I would only be touching the first 50% of those 128. I wouldn't even be adjusting any of the other values within the shadows. This gives you control. The amount is how much you want to turn up the rheostat or turn down the rheostat, or think of it as a dimmer switch. How much are you turning up the contrast on the shadows, or how much are you turning down the contrast on the shadows? You have that ability to control this function very succinctly. And it is probably one of the most advantageous tools as well. Also, ladies and gentlemen, one of the things that we get into when we are dealing with shadows and highlights is one of those functions that you must convert the image to grayscale before attempting to use this technique or to use this process. Failure to convert the image to grayscale will cause this process to be altered. And you want to be very careful with that process. Okay, so again, the amount is going to determine how much in contrast that you're going to increase or decrease. The tone is which of the values within the shadows range, i.e. your 256 shades of gray, which are then divided into the 128 shades of gray for shadows, 128 shades of gray for the highlights. The radius is the sample, and this is the sample block, I should say more specifically. You want to keep a very low radius. I very rarely, if ever, even move this off the default of 30 pixels because it is something that is pretty much fixed for almost everything that we do in terms of trace evidence. Same types of settings for the highlights, again, just so that you can see we have highlights, we have the amount, we have the tones, and we have the radius. So just remember on the shadows that as you increase the amount, that it's actually going to make the shadows darker. And if you increase the amount on the highlights, it's going to make those brighter. So you have to think about sort of the opposite rule of law when it comes to how pixel contrast is determined. So your brightness and your midtones, this is sort of the finishing touch when you get down or when you are done with the rest of the processes with shadows and highlights. Again, one of my favorite tools in the entirety of the arsenal of tools that we have for trace evidence. Levels, as I said before, you have your different ranges. If you are adjusting the shadows, it's going to create a problem where it can clip values, and also it pushes and shoves every single grayscale value within the image. Not good. We have the sliders for the highlight slider. If you are going to use levels, if you have to use levels, or if you feel compelled to use levels, the only thing that I suggest that you do is adjust the midtone value. Do not make any other adjustments to that process. When we get into curves, I always like to tell people, think of it sort of like a seesaw or a teeter-totter, whatever you want to call it, so that when you're adjusting the curves, one side of the grayscale values will increase in contrast, one value will go down in contrast. The only problem that you have to be considered, or the only issue you have to be concerned about, is where does the artifact fall in terms of where or what side of the histogram does that contrast fall. Because if it's on the wrong side of the histogram, as you bring the contrast down for the background, you can also change the contrast for the artifact that you're trying to visualize within the image. Again, just like curves, curves can be destructive. The thing is, you want to create a nice bell curve when you're trying to do your processing. You do not want to flatline either on the left side of the curves line or at the top. So flatline top or bottom, left, right, that is a horrible, horrible process. And it is destructive, and it is the same thing as levels. Also, when we're trying to isolate different tools, we get into a number of tools. Again, these are tremendously helpful when you're dealing with footwear impressions, whether it's marquee, lasso, or your quick selection tools, so that you can select specific areas. There's one mandatory requirement when you are dealing with the area of interest tools, and that is you must feather or blend your selection. So when you are setting up the selection, if you've selected the area, you could go to select, modify feather, and set your feather radius. Or if you think about it in advance, prior to selecting the area, on any of your area of interest tools, there's a feather option on the tool options bar at the top of the window in Photoshop. Now, for most trace evidence, typically, depending upon the size of the area, you may have something as low as a feather radius of 10, but you could also have something as high as a feather radius of 75. That is pretty much the limit when dealing with things with trace evidence. It also has to do with how much is that going to be blended within the image. One of the reasons why this becomes so important is if you fail to feather, then you can create artifacts within the image. We also have other tools to help fine tune our process after we've made these other corrections. We have burn and dodge, we have dust and scratches, and we have unsharp mask, which is part of filter, sharpen, unsharp mask. Now, I've got slides in here for you where you can read this in more detail as far as how this is going to be processed. For using dust and scratches, the typical range for the radius is between 1 to 5, and the typical range for threshold is between 0 to 50. Also, after you have gone through the process, you want to make sure that you've captured it, then make sure you save it in a non-compressed TIFF file format. And as we said earlier, do not ever save your processed images using a JPEG file format. When we get into compression, just to give you an idea what happens, here we have over on the left, this is no compression, and showing you the standard camera values. We have the process where we get into the fine compression. You can see that that one yellow pixel actually alters a number of other pixels within that value. When we get into the medium level compression, we see that we don't even see the value of yellow anymore in the image, but you can start seeing where this blocking is now starting to appear. And we get into our low quality, well, it still saying goes, we don't need no stinking yellow pixel. But the problem is that this is a significant degradation of image quality. If you're dealing with PDF compression, there are a number of people in the trace evidence community who still try to use PDFs for sharing the information. The PDF compression is significantly, I mean, it is like 10 times worse. It is your standard compression on JPEG. So by default, using standard Adobe PDF settings, the object level compression is set for maximum. So you can see how that's going to actually degrade the quality of the image. But it gets worse. When you're using a standard default PDF settings, images that have a resolution that is greater than 225 pixels per inch, they are first downsampled to only 150 pixels per inch. Then they are compressed using standard JPEG compression, and it's set to the medium image quality. These are the default settings. And this is something that 90% of people who are using PDF documents to share or exchange information, to share or exchange documents, if they have graphics in them, they have absolutely zero bloody clue as to what's happening to the quality of their images. And this can be horribly demoralizing, especially when you're trying to explain to someone why they cannot see the artifacts in the image when you've gone through that process. Again, once that data is lost, you can never recover it. So the thing that we want to do is always make sure that we are going to be able to visualize our data and to clearly demonstrate or illustrate those artifacts on the screen. Now, because of resolution of the screens, the monitor, the resolution of the file, the resampling to size it, to scale it, to fit onto the screen, all of those things can have a significant impact on how you even visualize that data. So one of the things that I recommend is, sure, capture the full image, then you can use your overlay process. You can take your dust print, overlay it over the known, and you can show where the consistency between the dust print or the print that was left in the dust actually matches up with the artifacts that are in the shoe. Now, one of the things that I also recommend doing is that you want to take up close pictures. And so this way you can actually very clearly see, for purposes of comparison, where those artifacts are actually visible within the image. So the whole process from beginning to end, to capture the image, to process it, to then start being able to use your high quality processed images to then be able to make your court exhibits and illustrate or demonstrate how this image then actually came from the known impression. Okay, so these are just a few of the techniques that are available. So thank you very much for your interest and for your attention. And let's see if there are any questions.
All right. Thank you, David, for such a fantastic and informative presentation. Since we're short on time, we'll dive right into questions, Q&A real fast, but I do want to mention that we'll have David's email up in a little bit for anybody who had a question that didn't get answered or we just ran out of time. But for now, let's get right into some questions. First ones that I have came at the beginning of your presentation when you were talking about file formats. What about .bmp? Is that an okay file format?
BMP is not really an acceptable file format for two reasons. Primarily, one is that a BMP file is what they refer to as index color, so that it means you do not have true accurate color fidelity within the image. And secondly, BMP files are typically not calibrated files. They have a resolution, but there is no distribution of resolution over a set number of measurements, such as pixels per inch, pixels per centimeter, etc.
Next question I have here, would you recommend not scanning latents developed with ninhydrin? I think I pronounced that correctly. Would there ever be a situation where it would be okay to do that versus taking a picture?
I am a very strong advocate for photographing all types of evidentiary photography, primarily because of the difference in the light wavelengths that you have available when you're using a digital camera. Flatbed scanners are very restrictive in the amount of contrast, and because it is an additive process with the red, green, and blue values, that it does not give you the most accurate and reliable distribution of pixel values or color values within those pixels. So yes, under certain circumstances, if it's a clear enough ninhydrin print, then yes, you could probably get by with scanning it. But again, you have so much more control over lighting, the ambient color length. You have the ability to adjust the white balance, which will significantly impact the background when you're trying to suppress color values, even if you're trying to use a tool such as calculations to suppress the background in a ninhydrin print. That will work much better with a photographed impression as opposed to a scanned impression.
Understood. Thank you. Another one I have here, if it's absolutely imperative that I rotate an image, such as for purposes of comparison, what is the correct or best method for rotating that image?
When you're using Adobe Photoshop, there is a tool that is called the eyedropper tool. One of the functions under the eyedropper tool is a function called the ruler tool. With the ruler tool, you can actually draw an axis, i.e. something that is centered either horizontally or vertically within the image. And you can actually use that axis and the option in Photoshop to straighten layer. That will give you the best possible result for actually rotating the image. But again, I never encourage you to rotate an image unless it has already been saved. Because once you rotate the image, no matter what method or what technique that you use, is if it's rotated at anything other than 90 degrees, you're creating artifacts in the image. If you ever need to go back and try to suppress background color values or make any other change, that if it has been rotated, you cannot go back and actually make that adjustment properly.
Understood. Another question I have here, besides Photoshop, what other image processing software would you recommend?
I don't recommend any other image processing software. Adobe Photoshop has tools that are developed in accordance with the actual development standards that we have to have. They're not open source applications, so they're actually developed within a controlled environment. Also, Adobe Photoshop has been accepted within the forensic science community since roughly mid 1990s or early 1990s for that point. So again, it is a tried, proven, tested, and accepted tool.
Makes sense to me. What is the most accurate and reliable method for adjusting contrast in a digital image?
The most accurate and reliable method is apply image. And the reason why it is the most accurate is that when we use the tool apply image, we are applying the brightness or the intensity value of each pixel to its corresponding pixel value. In other words, each pixel is dependent upon itself for its increase or decrease in contrast, depending upon the function that we are using. Any other tool that we use, even as much as I love shadows highlights, that with shadows and highlights, you can still adjust a cluster or a group of pixel or grayscale values of pixels. And again, you're adjusting a group at a single time. Now, again, apply image and shadows and highlights are the two most reliable, most dependent, and most non-destructive tools that we have available. And also one of the questions was whether or not you can actually see the adjustments happen as you're using shadows and highlight sliders. And if you have the preview option selected in shadows and highlights, you will indeed see that.
Awesome. Thank you. I know we're almost out of time, but I would like to end on this question because I think it's a good one to end on. Is it important to always follow the same sequence / steps when processing digital images? Or if not, why?
As a general rule, we want to follow a standard set sequence of processes. However, no two digital images are identical. Therefore, sometimes we may need to adjust contrast before we, or excuse me, I'm so sorry. We may need to adjust the noise in the image before we adjust the contrast. Because if we start bringing up the contrast, we are going to further exacerbate the noise issues that we have within our image. And again, there's a general rule that we follow, but that's not always going to be identical for every single process.
Awesome. Well, thank you, David. We are out of time, so we'll go ahead and start wrapping things up. I want to thank you for taking the time out of your day to present today's material, present the material that you did on Tuesday. It's been extremely well received. It's been fantastic overviews and even some good in-depth details about digital imaging processing and what to do. So thank you again for taking the time to present the wonderful material.
Thank you. You're welcome.
And again, everybody in the audience, I know we ran out of time. David's email is up on the screen now. So if you had a question that we didn't get to, or if you come up with anything else after the webinar, please feel free to reach out to him, and he'll be happy to answer your question when he can.
We would also like to take this time to thank our audience for joining us today. These webinars would not be possible without your attendance and support. Before you leave today's webinar, we would like to ask you to participate in a short survey. You can locate that link back on the webinar's main page. Simply click the word survey, and that will bring up our quick customer satisfaction survey for today's event. Your feedback about our webinars is vital information that we use to provide you with the best webinar experience and adjust the content and the way we disseminate the information to our audience. One more thing to draw your attention to, You should see we are putting links into the chat to all our social media pages, such as Facebook, LinkedIn, and Twitter, as well as a link to our website at forensiccoe.org and a link directly to our podcast episodes. Make sure you are following us on social media and subscribe to our newsletter to stay up to date with everything that FTCOE is doing in the forensic community. Thank you again for attending, and we hope everyone has a great rest of your day.